name's Brian Law. We're here today to have a look at the assembly of the latest clock, clock number 12. Show you in a second all the bits and pieces that have been made for the clock, and then we'll go through the process of putting it all together. Just a quick word about the clock itself. It's a new design. It uses a spring instead of a weight, and it has a short pendulum. All in all, it means it's quite compact, and you can use it to fit on a shelf on the fireplace. It doesn't need to be attached to the wall, and it makes it quite handy to be able to move around. Right, this is the first thing we're going to look at. This is the main shaft with its two gears. This is similar to the other two shafts on it, so just go through this once and show the basic construction of it. There's a central spindle which is made of steel. There's a sleeve that carries the two gears, which is made of wood, and there are the two gears themselves. The gears are actually glued to the central shaft and pinned. There's a pin through here, and we can't see it, but there's also a pin through that one. This is stopping it turning when the load is applied. The important thing with these, to get the gears running concentric with the shaft itself, is that when we initially make the sleeve, we leave extra material on at each end so that it can be turned down later. And to do that, after having made the sleeve, we mount it onto this spindle, then put the spindle into the lathe, and then finish off turning the ends. Then we fit the gears on, glue them in place. That way we'll get a perfect alignment of the gears on the shaft, so that they run perfectly concentric on this side just here. To put these in, quite simple really. They're a tight fit in the hole. Press them in gently for a start, and then make sure that you get them level and press down firmly to get them flush with the top surface. And in the case of the back one, get it flush with the back surface. The next step is to fit the escapement. This is mounted again to a steel shaft. It's got pallets fitted on either end. These can be adjusted later on, but at the moment we've set it so that it's in the right position relative to the end of the shaft. That simply goes into the top hole. The next gear to go on, which is the escape wheel, that's fitted provisionally just here, whilst we then fit the secondary shaft gear on the secondary shaft into that hole there. Get that down, and away it goes. Engage the gears at this point here, and now we take the main shaft and push this through the spindle sleeve here and down into into the gear, the bearing at the back. Okay, that's the three gears placed into the back frame. The next step is to fit the threaded rods and the spacers. So if I in this stage, what we're going to do is to fit the spring holder, which is this device here, and we saw this assembled on the short video earlier. It's the casing, there's a gear fitted to it, there's a front panel which is screwed in place, there's the gear inside, and there's the arbor, which is held between the two bearings. We now need to fit this onto the frame, so that it's ready to supply the power to the clock. And we do this simply by placing the gear through this hole and then attaching it on the back side using this bracket, which is secured with a screw here. Screw in and tighten up, slip it up. Now that spins nice and freely now, and it just remains for us to put the ratchet component onto the front here so that we can wind the clock. Now I'm going to have to try to align the holes. I'll spin through this. We fit the ratchet component over here and pin it in place with this pin. Okay, so that's now secured in position and ready for winding. Well, the next step is to fit the front frame onto the back frame, aligning up all the shafts and the bearings and the sleeves. And that's the whole assembly now fitting quite nicely down. Now we've finished attaching all the pieces to the front face. The first is this pawl, which engages on the ratchet here to stop obviously returning. You can see how that is now winding the spring. Next we put the small gear that's fitted to the main shaft, which then drives this hour train of gears, which finally has the hour hand fitted and the minute hand fitted. Now we're going to assemble the pendulum, which is quite simple really. It's partly assembled at the moment. We've got the head of the pendulum with a little pin in it and a blade on it, glued into place. Got a carbon fibre rod to act as the pendulum rod, again glued into the head, and we've got a threaded plastic section at the bottom for the use of adjustment, and that's glued into the bottom of the carbon fibre rod. We've got a small weight that we put on here, and we've got a nut that we use for adjustment. And when I say adjustment, the actual timing of the clock is governed by the length of the pendulum, and the length of the pendulum is measured from this point here where the blade fits in the support and the centre of gravity of the whole pendulum, which is somewhere down here, and that's going to be around 250 millimeters. So we roughly set that up before we start and put it back onto the clock. When it's on the clock and the clock's been running for a while, if the clock's running fast, then you turn anti-clockwise to move the weight down. If the clock's running slow, you want to push the weight up, so you turn clockwise. Now we're going to fit the pendulum. For that, I just need to point out that this brass pendulum support at the top here, which has a groove in it, needs to be lined up over the centre line so that when you put the pendulum on, it hangs down vertically along the centre line of the clock. But before we put the pendulum in place, we need to put the yoke. And the yoke is the piece that picks up the movement of the pendulum between these two pins and transfers it to the escapement itself, which allows the clock to run. And you can see by my moving the pallet like this that the spring is already driving the gears, which is moving the escapement. Now I'm going to fit that on. This is a tightish fit into, let's get it mounted at the other end as well. This is a tightish fit onto the shaft because it needs to not move when the escapement moves. Now if I mount the pendulum now and pop it between those two shafts and give it a kick start, you can see that it is actually working. What you can probably also see is that the pendulum itself, the pallets, are not balanced properly. We're getting more penetration of this pallet into the escapement than on this one. So I need to stop it slightly adjust it. I've moved it the wrong way. Now it's gone too far the other way. And now it's moving just about right. Now it only remains for us to fit the dial. I haven't actually got any holes drilled into the back of the prototype, but there is tape, so I'm going to pop this on at this point here and simply press it into place as a temporary measure. And finally we can wind the clock and set it going. You can see immediately it's going because I slightly wound it before, but to fully wind it you need to give it about 12 turns, which is as much as the spring will take, and that should last you just over 12 hours. I'm not going to do it all now, but as you can see, the clock is ticking away. Now we've finished the build of the prototype, I'd like just to raise just a couple of points. The first is that it is actually a prototype that you've seen built and doesn't actually represent what you'll find in the plans. I've tried to use different materials just to experiment and see what those materials work like and what they look like in a clock. And I think in this case, although the Perspex works quite well, the white plastic really doesn't. And the other point is that the dial, traditionally again made of wood, has this time been created by laser engraving. It's a plastic base with a white coating on the surface, which is etched away with the laser to leave a clean, sharp line on the surface, which in this case I think looks very good. That's it really. The plans are now available on the internet. They will be very much the same as this, or those slight improvements have been made due to the building of the clock itself. So I hope you have a good time building it.